This video is on classifying matter. So in chemistry, we're going to learn about different types of classifications of matter, properties, and changes of that matter. So before we can get started, we have to know, what is chemistry all about? Well, chemistry is the study of the composition, structure, and properties of matter. And matter is anything that has mass and takes up space. So basically everything that is around you. Matter can get classified into two different categories, and those categories can get broken down into two more categories. So first off, we have matter at the top of our pyramid. Matter can be broken down into two different categories: a pure substance and a mixture. A pure substance is exactly what it sounds like, something that is pure. Something that is pure is either an element or a compound. An element is made up of one type of particle. So if we were to look at a periodic table, we would see that on the periodic table we have elements listed, so we could find carbon and hydrogen or sodium or magnesium. Compounds are a combination of elements. So when I have H2O, that's water. If I have CH4, that's methane. If I have PbSO4, 2, that's lead 4 sulfate. Okay. Mixtures are different than pure substances in that they are a mix of multiple things put together. I can either have a homogeneous mixture or I can have a heterogeneous mixture. Both of these have prefixes on them that tell us about what that mixture is. Homo means same, so we say that they have uniform composition. An example of this would be vanilla ice cream. Where hetero means different, so non-uniform or different composition, such as chocolate chip ice cream. I can see the chocolate chips in the ice cream. I can see the different pieces of my mixture in a heterogeneous mixture. In a homogeneous mixture, I can't tell the different parts in my mixture. I just know that multiple things are mixed together. States of matter can be classified as either a solid, a liquid, or a gas. I'll give you a moment to copy down the particles, and then we'll talk about what they're going to do. So we have solids, liquids, and gases. Particle spacing is important. A solid particle spacing is going to be very close together. They're going to form some sort of uniform structure. Whereas a liquid, we say that liquids are kind of slippery. They glide past each other. They no longer have a uniform kind of way about them that's kind of nicely packed together. They kind of move back and forth. Gases are even more spontaneous and they move around even more. Okay, gases is going to bounce all around. These have lots of energy behind them. Okay, they're moving very fast. They're bouncing off the walls, right? They're zooming all around, and they don't have much in terms of, or they have lots of space between them. Okay, so they're spaced really far apart. Liquid particles are close together, and then solid particles are the closest. Now, attractive forces, how much attraction does this molecule have to this one? Well, in a solid, they're very close together, so they must have strong attractive forces, whereas gases are really far apart from each other, so they must have weak attractive forces. They don't want to be next to each other. They're not attracted to each other at all. And then our liquids, we'd say that they're moderate, or they're in the middle. They're kind of attracted to each other. They like to be close to each other, but they're not nearly as strong as a solid or as weak as a gas. Now their shape, the shape of a solid is definite. I can look at something, I can look at this pen and see, yep, this is this shape, right? So if I had a cube, that's a solid. We can see it has a definite shape. right? I can see exactly how it looks. Whereas a liquid has an indefinite shape. Okay, a liquid is going to take the shape of its container. So if I were to put a liquid in my cup here, my liquid might be in a rectangular cup, but when I put it in a circular cup, it's going to take its shape and become a circle. Gases have an indefinite shape as well. However, just like the shape of our liquid, how the liquid takes the shape of the container, so does a gas. Now the volume of these is also going to vary. The volume of a solid, just like its shape, is definite. So if I were to put a volume or a solid in my cup here, my solid, if I had a cube, is going to sit at the bottom here of my little container. It's going to hang out. It doesn't matter how big or small of a container I put this in, but my solid is going to sit in every container just like so. If I put a liquid in my container, if I put in, let's say I put in 50 milliliters, that's how we measure volume, milliliters of water into my container, that's going to come up to about here. We'll say this is 50 milliliters. And my water is going to fill just 50 milliliters of my container. Doesn't matter how big or small my container is, it'll fill 50 milliliters. So we say that liquids have a definite volume. It's always going to have 50 milliliters. Now it takes the shape of the container, but it's only 50 milliliters. A gas, however, if I had to put a lid on my container, so I'll close off my container here, I put a lid on it, okay, and I fill that with gas, my gas molecules are going to fill my entire container. So they spread out until they fill every nook and cranny of my container. So we say not only does it have an indefinite shape, that it takes the shape of its container, but it also has an indefinite volume. So now I'm going to look at what are some of the properties and changes that we have between our states of matter and between our different elements, compounds, and our mixtures. So the first property that we're going to look at are physical properties. Physical properties are characteristics or properties observed without changing the substance. So I can look at my pen and I can see that it's brown. I can look at the paper and see that it's white. Okay, so examples are things of our five senses. The color, the texture, the smell, the taste, the length of something. A chemical property is going to be characteristics that we observe when a substance changes in composition. So the big difference here is that we change for chemical properties and we without changing, so we stay the same with our physical property. So examples of chemical properties where I change my substance is something that's flammable, or reactive, or toxic. That's all going to change the items that I have. Now I can have physical and chemical changes. So a physical change is where the form and shape are going to change, but we still have the same substance. So it's still going to have the same properties. So for example, anytime I go through a phase change, I melt something, I freeze it, I boil it, I still have my same substance. I've just changed the state of matter that it's in. I could cut it, I could dissolve it, I could mix sand and water, and again, I still have the same thing. So if I take a piece of wood and I cut it in half, well, I still have wood. Or if I take salt and I dissolve it in water, well, I've dissolved my salt, but I haven't destroyed it. I can evaporate my water and get my salt back. Or if I'm mixing sand and water, I can drain off the water and still get my sand. So different things that we can do to something, but we still have the same substance. Whereas a chemical change, well, a chemical change is when one substance is transformed into one or more new products. So I've transformed it, I've created something new. So this is composition changes because our particles here are rearranged. So going back to before, that means those elements are getting rearranged. So examples would be cooking food, burning wood, rusting, digestion, so breaking down your food, something's decaying. Okay, all of these things, we can't go backwards anymore. We can't get back what we started with like we can with dissolving or phase change. So these are one-way streets. We can't ever reverse it, and that changes it into something new. Okay. So that leads us to, well, what are these chemical reactions? We know in chemistry we have chemical reactions, and we'll spend a whole unit talking about them. And a chemical reaction is where one or more substances are changed into new substances due to our particles being rearranged. So we'll eventually be able to predict this, but without even thinking about the actual elements, but we should be able to look at something and say, yep, that's a chemical change. There are 5 indicators. So color change, if we release bubbles or we make a gas. If we produce an odor, so some things give off really good or bad odors when they're reacting together. If we make a solid, so a precipitate is made. So precipitate is the fancy word for solid. Or if we have a temperature change. So this is not heating something or cooling something, but mixing 2 things together and having it really hot or really cold without changing its temperature by force. So we'll find that there's some reactions where we'll have 2 liquids at room temperature, we'll mix them together and it'll get really hot. Or this is how your hot hands work when you're going outside in the winter and you want to keep your fingers warm. And then what does this chemical reaction look like? So you might see things where it's like A plus B goes to C, or C breaks down into A and B, or A plus B makes C plus D, and of course it's not nice with A and B, it's these weird chemical compounds. But overall, anything on the left of this arrow, so this part here or here, these are all reactants. So they're reacting together to make or produce our products. So anything on the right of our arrow are our products. And the arrow just means like yields or to make. So we react things together to yield or make products. So reactants are on the left, products are on the right. So a reaction to make something that you probably have on your kitchen table or in your kitchens at home is we can react sodium metal with chlorine gas to make sodium chloride. That's table salt. And so if I write that in my chemical symbols, sodium we know is Na. We put a little S after it because it's sodium solid, plus chlorine, and chlorine's something weird called a diatomic. There's 2 of them put together, and that's a gas. And so I can put chlorine gas around sodium metal, and I'm going to make sodium chloride, which is NaCl, and that's a solid. So it's a pretty cool reaction. We won't actually do it, but we might watch a video on it. But we can see that here are my 2 reactants. They come together with this plus sign where they yield my product of sodium chloride.